Okay, on this one's a little strange here because it's a 30, 60, 90 triangle, but the side that typically has a square root is going to have the side that typically has a square root's got a whole number on this specific example. So let's talk about how we're going to approach this one here. So I'm going to put s square root of 3 next to that 6, and then of course s and 2s over here. And I'm going to write this, s squared of 3 equals 6. And we technically need to get s by itself. So we're going to do that by dividing both sides by square root of 3. And that's going to cancel out the square root of 3 on the left. But on the right hand side, you're going to have s over square root of 3. All right, and then we have that process called rationalizing the denominator, where you have to get rid of the radical in the denominator. We do this by multiplying top and bottom by square root of 3. And that's going to give me 6 square root of 3 over square root of 9 when you multiply. And then square root of 9 is going to be regular 3. And then the 6 and the 3, those are going to reduce, and you're going to get s equals 2 square root of 3. Okay, and then once you're done with that, then you can go and put 2 square root of 3 down here at the bottom, and then over here you need to do 2 times 2 square root of 3 for the hypotenuse side right there, and that'll get you 4 square root of 3. So that one's a little bit more involved right there on that one. 45 is pretty similar, except it's dealing with the 45, 45, 90, but you're going to have a whole number once again for a side that typically has a square root. So it'll have a lot of the same steps here. I think I was calling these L earlier in the unit. You can use L, you can use S, you can use whatever letter that you want there on those. But anyways, let's try this out here. This one you'll go s squared of 2 equals 8. So once again, the process is divide. Okay, I don't have any room to work with here. And then multiply top and bottom now by square root of 2 instead. That's going to get us 8 square root of 2. And I'm going to skip a step here. Square root of 2 times square root of 2, of course, is square root of 4, but that's going to be regular 2. And then once you reduce the outside numbers, and only the outside numbers right there, that'll be 4 square root of 2. And that'll be both of these sides right here. That's what s equals. S is 4 square root of 2. This s right here is also 4 square root of 2. So that's going to be your approach there on that one there. The only last kind of weird example I can give you is where I give you a square root on a whole number side. So this one kind of looks like this right here. If s equals this whole thing, then I need to take that whole thing and multiply it by another square root of 2 right here. So the s square root of 2 side, I'm going to substitute in for s. That's 2 square root of 5. And then I'm going to multiply by an additional square root of 2 right there. That's going to be 2 square root of 10. And that'll be that side right there. Oops, 2 square root of 10. And then this side over here was going to say 2 square root of 5. Okay. Now that is when you are trying to find a missing side given one side in a missing, or in one angle, I guess I should say. Given one side and one angle, you can go find those specific sides if it's one of those angles of 30, 60, 90, or 45, 45, 90. Now, when I just give you two sides of a right triangle, don't forget about your Pythagorean theorem. A squared plus b squared and then equals c squared. And we only do that on right triangles. So you got a right triangle going on here. Now, as far as your A's and B's right there, those are the two legs. C is always the hypotenuse side. So when we set this up here, I'm going to go x squared plus 12 squared equals 20 squared. Okay, and 12 squared should be 144. Or I'm sorry, 12 squared is 144. 20 squared is 400. Okay, after that, we'll go ahead and subtract. You can just do 400 minus 144. 256. Now, sometimes they'll be perfect squares, sometimes not. So you would square root both sides. And on the test, you're going to need to be able to do simplest radical form. But before you do that, let's go check and see if it's a perfect square. So I'll just do the second square button and then square root of 256, and that does come out to 16. Right there. Now, if it doesn't come out to a perfect square, you're going to do your prime factorization trees and then pull your pairs outside of the groups, or outside of, I guess, the radical. Let's see what's going on here with this one. I think this one will have one where we need to break down the radical. So kind of like the last one here, a and b are these sides, c is the 10 right there. So we'll go x squared plus 4 squared equals 10 squared. This should be 16, and then this should be 100. And then after you subtract, we'll get 84. That is not a perfect square. Watch this. If I do square root of 84, that's going to come out to a decimal. Now on the test, I'm going to ask you guys to do simplest radical form. All right. Now most of the times, if you can get to square root of 84, you might be able to get some partial credit here. Make sure you break down with a prime factorization tree. So as far as numbers that multiply to 84, you can use any two numbers you want. If you don't know where to start with 2 and something. 2 or 3 or some small numbers here. So that could be, what, 2 and, that'd be 42 right there. 42, you could go 2 and 21. And then, of course, 21, you can go 3 and 7. The only thing that comes outside of the radical is going to be your pairs. And you write one number per pair. So if I got 2 groups of 2, I'd write 2 twice. I only got one group of 2 right there, so I'll just put 2. Anything that doesn't have a group, you multiply back together. 2 square root of 21 is what you're going to do for your side right there. So pairs come out, non-pairs stay in, and then you just multiply them all together.